We're going to be solving equations by adding and subtracting. And we haven't talked a whole lot about equations, but we have talked about expressions. And so we're going to define equations, and we're going to talk about how to solve equations using addition, how to solve equations by using subtraction, and how to solve equations by adding the opposite of a number. So an equation is a mathematical statement that two expressions are equal. So if I have 3x plus 7 equals 2, I have the expression 3x plus 7 and the numerical expression 2, and when I say they're both equal, I end up with an equation. And equations look very different sometimes. You could have something like 3a minus 6 equals 2a squared. Now we won't do anything like that in here, but this is an equation. I have two expressions, one expression, two expressions, and an equal sign. Therefore, we have an equation. And when we solve equations, we look for solutions. And a solution of an equation is the value of a variable that makes an equation true. So if I say 3x equals 6, that means 3 times x equals 6. And if I want to solve this equation, I have to find the value for x that makes this expression equal to 6. So I get 3 times 2 equals 6, so therefore x equals 2. This is the solution to that equation. The value 2, when I plug it in here, I get 3 times 2 equals 6, and 3 times 2 does equal 6. So therefore, 2 is the solution to the equation. Now, to find solutions, we isolate variables. And what we mean by isolate variables is this. We mean that the variable is going to appear by itself on one side of an equation and not at all on the other side. In other words, if I have x equals 2x plus 6, I have not isolated the variable because I have an x on both sides of the equation. I need x only on one side. Now I can have 3 equals x, that's isolated, or x equals 4. That's isolated. So both of these have x isolated. Now the question is, how do I get from something like this, 2 plus x equals 5, to get x by itself on this side? How do I undo this 2, get rid of this 2, so that x is isolated? And that's what we're going to learn today. We isolate variables by using inverse operations, and these inverse operations undo the operations. So what we do is, if there is addition going on, the inverse operation is subtraction, and subtraction undoes addition, and vice versa. Addition undoes subtraction. But the key here is that we have to know that if I add something on one side of an equal sign, I have to add it to the other. If I subtract something on one side of an equal sign, I have to subtract it on the other. And that works for all four operations. We have to do anything we do on one side of an equation, we have to do on the other. So let's start with this. We're going to solve this equation, and we want to check our answer. So we want to solve the equation. The variable is n, so we want to solve for n. Okay, so we want to solve for n, and I say that n, what's happening to n? On this side of the equation here, okay, so I have equals here, and this is where n is, and what's happening to n? 3.2 is being subtracted from it. So the inverse operation of subtraction is addition. So normally what we would do is we would say n minus 3.2 equals 5.6, and then I like to just draw a line underneath this like this and say the opposite here, the inverse of that, is to add 3.2. and then anything I do on the left side, I have to do on the right. So I'm going to add 3.2 here also. Now the idea here is that this is going to give me 8.8, and over here I'm going to get, I have negative 3.2 plus 3.2, so what I have really is n plus 0, and anything plus 0 equals itself. So we have isolated the n, and we think that the solution here for n is 8.8. We think that 8.8 minus 3.2 equals 5.6. So we have to check this. This says to check our answer, so we have to check it. So what we do is we write the equation that we were solving. We substitute our supposed solution in for the variable. And we simplify on this side. 8 minus 3 is 5, and 8 minus 2 is 6. So we're going to get 5.6 equals 5.6. So we get a true statement here. 5.6 does equal 5.6. And that's the goal. Remember, the definition of a solution is a value for the unknown variable that satisfies the equation. It makes this equation true. And when I substitute 8.8 in for n, I get a true statement. It makes my equation true. So now I want you to pause and then solve b minus 5 equals 8. Okay, so since we're subtracting here, the inverse operation of subtraction is plus. And we're going to do that to both sides. We're going to add 5. And remember, negative 5 plus 5 equals 0. So I'm left with b plus 0 equals 13. Because 8 plus 5 is 13. And b plus 0 just equals b. So b equals 13 here. Now we want to check the answer. So we're going to say b minus 5 equals 8. And 13 minus 5 equals 8. And 13 minus 5 is 8. So we have the right answer. We have the right solution. B equals 13. Now, the variable, notice the variable's on the other side of the equation. Well, this shouldn't change anything, okay? I have m minus 9. What's happened is 9's being subtracted from m, so I'm going to add 9. I'm going to do that on both sides, because if I don't, I lose my equality here. Okay, so I get m. Some people say that cancels because it equals 0, and then we can just forget about it. And 16 plus 9 is 25. So I have m equals 25, and I have to check my answer, so we're going to try that. 16 equals 25 minus 9. And 16 equals 16. So we are correct. Okay, now next we want to try another one. But this time I have a negative number over here. So I want to know x minus 8 equals negative 3. Add 8. Okay. And I'm going to get x equals, and 8 plus negative 3 is 5. So 5 minus 8 equals negative 3, and it does. This is the check down here. We're checking. Check your work. And so we're good to go. And now we're going to solve an equation in which something's being added to the variable. And as we spoke of earlier, the inverse operation of addition is subtraction. So we're going to just subtract that from both sides. So now I have negative 5 and negative 5 here. Negative 5 minus 5 is negative 10. Okay? So that equals k. And we're going to have to check this. So negative 5 equals negative 10 plus 5, and negative 5 equals negative 5. That is correct. So the solution here is k equals negative 10. Now we have a problem because we can't subtract t. I mean, we can, but we're not getting anywhere. So we want to try to solve this and get rid of this 6. And when I say get rid of the 6, we want to undo what the 6 is. So what we're going to do is we're going to add the opposite, or just we're going to look at the sign in front of the 6. Is the 6 positive or negative in this case? And the 6 is positive, so we're going to subtract 6, because remember, we want this to be 0 plus t, because anything plus 0 is itself. And remember, I got to do that over here now, and I'm going to get 8. So I get t equals 8. And I'm going to try that here. I'm going to plug it in. Plus 8 equals 14. Uh-oh, I'm sorry. And this, we're going to get 14 equals 14, and that is correct. Okay? So, let's look at another one. And this is exactly what we're trying to say here. In many instances, the constant will come before the variable in the equation, just like the last problem. And in these cases, it's easier to add the opposite of the constant in order to isolate the variable. Adding the opposite is the same as subtracting. So here, I'm going to add 6, because this is negative, and negative 6 plus 6 equals 0. And I want to have 0 plus s, and I have to do this over here, and I'm going to get 11. So this is an s, not a 5. I know it looks like a 5. So I get s equals 11 here. Okay? Now let's check our answer. Negative 6 plus 11 equals 5, which means 5 equals 5, and we are correct. Now sometimes if you ever come up and you don't get a true statement here, you've made a mistake over here. So there's really no reason to ever get a problem wrong when you're solving, because you can always check your solutions. Okay? Now pause and see if you can do this problem. Okay, here we go. And although the a is on the opposite side, the constant of the expression where the variable is before the a. So we're going to add the opposite. We're going to add negative 6. Okay. And I'm going to add negative 6 here, which is the same as subtracting 6. And I'm going to get 4 equals 0 plus a, which means 4 equals a. We're going to go ahead and try. 10 equals 6 plus 4, and 6 plus 4 does equal 10. So we're correct, and we'll move on. And that's it. So the idea here is that we're going to use, let's just summarize real quick what we're going to do. We're going to use inverse operations to isolate variables on one side of the equation, and this is going to give us a solution. And don't forget, the definition of a solution to an equation is any number that can be substituted for a variable to make that equation true. Okay?